Hey everyone, so in this video we're going to talk about equations that have complex roots. Now, to understand what complex roots really mean, I think it's useful first of all to look at what real roots are. So if we have a quadratic equation that crosses the x and y axis, here's our x axis, here's our y axis. This equation has two roots and the roots are located where it crosses the x axis. So a lot of equations will have roots. Some will have one, some will have two, some will have three, or even more. But some also will not. So here's another example. If this was to be a quadratic equation and it kind of reaches its minimum point here and turn back up, well, that does not cross the x-axis at any point, so it doesn't have any real roots. However, we could still fill it into the minus b formula, and what we'd find is that a complex number comes out as the answer. So that's why we say that this has complex roots. So we'll look at a specific example of that now. So the example we'll look at is z squared plus 2z plus 10 is equal to 0. Now, usually at this point you'll have seen this kind of a question as part of a bigger question on complex numbers. So that might have given you an indication that you're going to end up with a complex answer. Another clue is going to be the letter z. A lot of the time when we see z, it means that we're dealing with complex numbers too. So if we try and solve this using all of our other methods, we're going to run out of them and we're going to have to resort to using the minus b formula, which we all know and have practiced using to solve a quadratic formula that has a square in it as the highest power. So the minus b formula is minus b plus minus square root of b squared minus 4 ac all divided by 2a. Now a here will be the number in front of the squared, so just 1. B will be the number in front of the regular z, so that's 2. And c will be the number at the end by itself, which is 10. So if we fill on this in, we're going to end up with the following. Minus 2 plus minus the square root of 2 squared minus 4 times 1 times 10 all over 2 times 1. Now, we can start simplifying this and we'll see where our answer leads us to. And we'll simplify it one more time. So what's really key here is that we end up with a square root of a minus number as part of our answer. Now, when we started doing complex numbers, we learned how to write the square root of a minus number in terms of I. So we would split up a complex number. So in this case, the square root of minus 36. We can split that up into the square root of 36 and the square root of minus 1. Now the square root of 36 is 6, and the square root of minus 1 we call I. So the square root of minus 36 we can rewrite as just being I. So we get minus 2 plus minus 6i all divided by 2. If you remember using the minus b formula, the way we go from here is we solve this out twice. So we're going to have minus 2 plus 6i over 2, and we're going to have minus 2 minus 6i all over 2. So to solve the one on the left, just simplify it a little bit further. Minus 2 divided by 2 will just give us minus 1, and 6i divided by 2 will give us 3i. So we're dividing each of those terms by 2. Over on the right hand side, minus 2 divided by 2 will give us minus 1, and minus 6i divided by 2 will give us minus 3i. So these are two different roots, and you'll notice that each of them is a complex number. So that ties back to the title of this topic, solve an equation that has complex roots. What you will notice is that anytime you get your answer, the roots that you get are always conjugates of each other, so they'll be the same, but they'll just have a different sign for the imaginary part.